Alright, so what's up, guys? Today we're going to be doing math, but instead, not only math, we are going to talk about expanding Bionomals. I don't know if I wrote that right, but that's what we're going to be doing today. So, let's see this. Bionomals, yes, thank you. Anyways, so what we have here is an equation that is y minus 3 to the power of 3. And we want to expand it. And in to the power of 3, there is, you should already know, the Pascal's triangle, which helps show us the coefficients of this equation. So Pascal's triangle starts at 1 if it's like to the power of 1 for like the coefficients of this expanded equation when we expand it. And then it continues on to 1, 3, 1, then 1, 4, 6, 4, 1. It's like a big triangle, like a pattern. And then so on and so forth, it goes more and more down. So now to expand the equation, what we are going to do is first see the A and the B value. Let me switch the color for that. A, and then now the B value. So the A value is x. And the A value will always start with the highest power, which is 3. So that's going to be x to the power of 3 times negative 3, which is the B value, to the power of 0. And since the powers go 1, 2, 3 for this whole entire equation, the A is going to start with the highest power and the B is going to start with the lowest power until eventually at the end of the equation it's going to end up leading back to the B having the highest power and the X having the lowest power, or the A having the lowest power. So we're first going to start off with that. Hold up, let me make that smaller. Bigger. Let's see. So that's an example of what like the first term of the equation would be. And now let me make it smaller so we can fully have it. So now we're going to have, let's see, x to the power of 3 times, there we go, times, let's see, 3 to the power of 0. And then for the next one, it's add. It's going to be 1, because in Pascal's triangle, there are 3 terms in the equation, since it's to the power of 3. Then the next one, we have x to the power of 2, and then 3 to the power of 1, plus x to the power of 1 with 3 to the power of 2. And then finally, we have x to the power of, hold up, let me erase that real quick because that's 2. I will lead that back down to here. Then we have x to the power of 0 times 3 to the power of 3. So, now that we have that equation, we will put 3 at the end of that because that's the coefficient. That's going to be 3. And then, let me see if I... 1. So yeah. Anyways, so continuing with this, let's see. So first we see that we have 3 to the power of 0, and 3 to the power of 0 is obviously 1, and that's 1 right there, so that's just going to be 1 times 1 is 1, and hold on, let me just, what's going on here? Here we go. Yeah, anyways, so 1 times 1 is 1, so then that's just going to be x to the power of 3. X to the power of 3. And then we have for the second one, 3 times, let me write this out more clear, 3x squared times 3 to the power of 1. So then that's just going to be, since the 3 is on the outside, we have 3 x to the power of 2. So then that's just going to be 3x to the power of 2. And that's just going to be, times 3. So that's so far plus 3x squared times 3, and then plus, and then now we have plus 1 times x to the power of 1. So then that's just going to be x to the power of 1 plus x to the power, just x. And then that's going to be times, times 9. So then that's just going to be 9. So then just make it 9x. And then, so then that would make it x squared plus, since we also have to multiply these, 9x x cubed plus 9x squared plus 9x plus 27. Yeah, 27. So that is the final equation. And then now, if we zoom this more back out, I can have more space to do the second lesson, which is on expanding, not on expanding, but having E or having E compounded continuously. But for right now, I'm going to talk about how E works and natural log and those kinds of equations. So, okay. So for this problem, we have, figure this out, natural log times x plus 4 minus natural log 5 equals 3. So natural log, obviously, it's kind of like log, where it has log 10, but then on log 10 it doesn't show it. So ln and e are like similar with one another, so it's ln e. And first what we do to solve this is to move the e over here. So we have e to the power of 3, so that gets rid of the ln's. So then we have x plus 4 divided by 5. Since it's a minus right here, whenever there's a minus between two natural logs, that always means that they are going to divide. Let me write that in red. They are going to divide. Okay, so now that we have it like this, what we want to do to simplify it even more is times by 5, so we can move that to that side. So we have x plus 4 equals 5 times e to the power of 3. And then that will be, if we simplify that even more, if we figure out what e to the power of 3 is, you can use your calculator on that one, which is times 5. So then we have, let me get the eraser here so I can have more space. So then we have 5 times e to the power of 3, but then minus 4. So we have to subtract it. So x equals 5 times e to the power of 3, but then minus 4. All right. And I think that's somewhere around, let me get my calculator real quick. Let's see, 5 times minus 4. Okay, that is going to be 96.43. So that is our final answer for that. And, well, it was nice talking with you guys, and I'm going to see you later. This one is the natural log one. This one is the expanded version one. Bye-bye.